ahead. Just to make sure you know what we're working on here, we're working on Chapter 2 of the summer assignment, and we're looking in this section at naming compounds. So if you want to know more about rules for naming compounds, you can go to this website, and that is the I is International, and then Union of Pure and Applied Chemistry. And that's the naming system we're going to be using as we look at these. So whenever you see ionic compounds, well, how do you know this is an ionic compound? Because you see a metal at the beginning. All of these have metals at the beginning, and then we see a negative polyatomic ion. So we're going to just look at this first one, and it's going to be barium is the cation, and sulfate is the anion. And since barium only has one charge, we don't have to use Roman numerals. B, we look at the cation, and we see that it is sodium. And we look at the anion, and you have to be a little careful here. What is that anion? That's right, it is nitrite, not nitrate. Sodium only has one charge, so we don't have to worry about any Roman numerals. Potassium only has one charge, so we don't have to worry about any Roman numerals. And this is permanganate. And potassium dichromate. Potassium dichromate. What is the formula? Now here we see prefixes, right? So we know that these are two nonmetals, and all we have to do, let's figure out what boron is. Boron, and di means two, so there's diboron trioxide. That was easy. Where's your easy button when you need it? Arsenic pentafluoride. Now some people are going to occasionally classify arsenic as a metal. I'm just having to do a quick look. It is over there with the nonmetals, isn't it? Metalloid, but definitely can use the prefixes for naming that. Dinitrogen monoxide. There we go, dinitrogen monoxide. Sulfur I like sulfur hexafluoride. Ask me about it sometime. But this is sulfur hexachloride, SCl5. There we go. Name these. So as we're naming these, you're going to want to think about all the different naming protocol and systems we've looked at here. And we're going to start here by looking at three of these. This one, and this one, and this one. Are there any more? Now the thing that's really significant about these three compounds is that we have anions containing oxygen, and we are starting with hydrogen. Now these just happen to be acids. And so we want to look at how to name these oxygen-containing acids, or oxyacids. And so we're going to look at our rules for that. And since we're looking at A here, and A, here we have acetate and hydrogen. So we remember that we take the name of the anion and we just change the ending to this, acetic. So this is acetic acid. If we move down here to G, we have another acid containing oxygen. Now this anion is sulfate. That's the ATE ending. So that means we just change the ending to IC. So this is, and it's actually sulfuric acid. Oops, that's G. And then we're going to change here and take a quick look at L. Get the board erased. And so this is L. And when we look at L, what is that ion? Now, if it was, just if it was ClO3 minus, that would be chlorate, the ion that ends in ATE. This has less oxygen. In fact, it has 2 less oxygen. So we're going to put OUS on the ending, and hypo at the beginning. Hypo, remember, means underneath or less than. And so this is hypochlorous acid. Now, are there any of the others here that are things that might give you a challenge as you're learning or remembering how to name compounds? Now, I often see students struggling with B because B starts with a nonmetal. And so they're trying to name it with prefixes or something. Well, notice this is not a binary compound, so we're not going to worry about prefixes. You'll also notice right here a separation between the cation and the anion. The cation is ammonium. What's the anion here? Don't miss that. It is nitrite. Nitrate is NO3. Make sure you get that right. Let's move on to, let's take a look at C. The reason I want to take time to remind you about C, of course you've probably already written these and given some thought to C, but we see here, I'm going to rewrite it, cobalt and sulfur, and we see 2 cobalts and 3 sulfurs. What's the name going to be? Well, of course, this is sulfide, and this is cobalt, but cobalt can have more than one charge. Its transition element has more than one possible charge. What is its charge? Well, sulfide is always -2 for a total negative charge of -6. Of course, the positive charge on this must be +6. And since there are 2 of those, each must be +3. So this is cobalt, Roman numeral 3, why did I write sulfide? Oh, it is sulfide. Okay. That's why, because it's sulfide. And are there any more of these that are going to give you a challenge? Be sure you remember to use the Roman numerals here. Be sure you remember that some of these may be 2 nonmetals, and so you use your prefixes. And I think you can solve the rest of these. Good. Go at it. Number 66. I assume here we're supposed to write the formula for these. And so chromium, Roman numeral 6, oxide. So I'm going to write that up here, chromium, oxide. Of course, oxide has a charge of 2 minus, and this chromium is 6 plus. Now, there may be a few people who go, oh, I'm going to remember something called the crisscross rule shortcut, and I'm going to put a 6 there and a 2 there. No, not right. It has to be in the lowest whole number ratio. So it's actually CrO3 is in the lowest whole number ratio. So disulfur dichloride, that's going to be easy. Disulfur dichloride, nickel 2 fluoride, nickel 2 fluoride. Nickel is plus 2 in this case, fluoride minus 1, so we have to have 2 of the fluorides. Potassium hydrogen phosphate. Now, we have to have 2 of these, so the charges add up to 0. Potassium is always plus 1, hydrogen is always plus 1, phosphate is minus 3. So the total positive charge is 2 and 1 is plus 3, and the total negative charge is minus 3, and that adds up to 0. Aluminum nitride, don't miss that. Aluminum is plus 3. Nitride is minus 3, but not nitrate or nitrite. Be sure you get that right. Ammonium is not, or ammonia, sorry, is NH3, and that's a compound you should recognize by that name. You should recognize it as NH3. Okay. I think you can finish the rest of those. Now, what's incorrect about these? So you're going to take a moment for each of these to just write a statement with an example to show why these are incorrect. Well, the reason A is incorrect is we need a Roman numeral 3 here to tell which compound this is. Is it iron 2 chloride or iron 3 chloride? B, this is 2 nonmetals. It's a binary compound. We don't use Roman numerals. We would use prefixes. So this would be trioxide, nitrogen trioxide. Don't need a Roman numeral for calcium. It only has one oxidation state, and also we wouldn't need the prefixes here. This would just be calcium oxide. Only one possible formula for calcium oxide. Dialuminum trisulfide? No, this is a metal. Aluminum is a metal. Once again, we do not need the prefixes. So that's the kind of statements you can make, and they show the correct name to go with the formula that is there. So, for example, here you would just rewrite this as iron 3 phosphate. So go through, fix any of those, fix all of those. All of those are incorrect. And for the last question, the problem that students often struggle on here is not writing the correct number of protons. In other words, you all know that you just go to the periodic table and you look at the atomic number for iron and you say, iron, atomic number 26, 26 protons. And the charge, since the charge is plus 2, it has 2 more protons than electrons, so this must be 24. That part's easy. Now, but what confuses people is this. So what it's saying is if you have a cation here like iron, what's the formula if you combine it with an anion like oxide? And so they're just looking for this kind of a formula for iron with oxide. Now if we jump down to sulfur down here, which is I don't know why these letters do not seem to be in consecutive. So this is probably E, but I'm not sure about that. So be sure you check that out. We look at sulfur. Sulfur is atomic number 16, so there's 16 protons, but it has a couple extra electrons giving it a negative charge of negative 2. So this is 18. And here we're looking at sulfur, and what's it combining with? Aluminum. So we're looking at the formula for aluminum and sulfur. So you're going to be writing something like that. So good luck. Hope you're about done with your assignment and you have a chance now to check this out and see if you have it done correctly.